Hello, welcome to the supplemental Excel example for risk analysis. We're going to jump right into it. So basically we have three cash flows, a present value, an annuity, and then a future value. And we are being asked to find the expected value and standard deviation of the net present value after 10 years. There is a discount rate that we are unsure about. We believe there's a 30% chance that there's going to be a discount rate of 4%, so on, according to this table. So let's get started. So we are being asked to find the expected value of the net present value. So first, let's find the net present value for each discount rate. So equals P. I'm going to put our dollar operators in there now. Minus PV of the rate. Everyone should know how to do this by now, so I'm gonna not do too much explanation on this. And then our payment is $B $2 minus PV again of rate and per not a payment, it's a future value of 3. So we get this to be our net present value. So if the discount rate is 4%, the net present value is $1,225. Let's copy this down. You can see as the discount rate goes up, our net present value goes down, right? The $25,000 of an upfront payment is going to be a much larger impact as the A becomes less valuable. So expected value, if we remember the expected value formula, it is sum of the probabilities times the observation. So let's do P times observation, which is NPV in this case. So probability, net present value, do this, and then expected value is equal to the sum of this, which is the weighted average of the net present value results. Under no circumstances should you be using the average function built into Excel. It does not take into account your probabilities associated with everything, so it would just take a direct average instead of a weighted average. Same thing with the standard deviation function. You can't just take the standard deviation of this group. You need to account for the probability. So we're going to do that manually. So next we want to find the standard deviation of the NPV. If we remember correctly, that function is the square root of the sum of P times the observation squared and then minus the expected value squared. So let's do P times NPV squared. And that's going to be equals to this times this squared. And go ahead and drag that down. So that's all of those, and then it's going to be equal to square root of sum of all of these minus this squared. Let's end our square root function and hit enter. So we get a standard deviation of $1,242.46. Our expected value is negative, so the project is likely to be negative. The standard deviation is very large relative to the mean, and so we would expect our observations or net present values to hit a wide variety of values, which you can see because each of these is pretty spread out, right? The total range of the NPV as the discount rate goes up is pretty high, so we would expect to have a large standard deviation. That's about it for risk analysis. Don't forget that any of these values could have an associated probability associated with it. So if I ask you something on the test like the life of the project follows the following distribution with the probabilities, We expect you to be able to solve that. Same with if the value of A is different according to the certain given probabilities. We expect you to be able to solve the expected values of any of these stuff. They're pretty common basic statistics that you need to know. Anyways, thank you very much, and good luck.